Hello and welcome to the EEPROM 9. Today's teardown, Deja Vu, Dynatech Communications, Dynamite Free, which is the most awesome name. Some of you will remember that, and yes, I have done a previous teardown, but I also pulled a second one out the skip which had been vandalised to no end, so I have completely just dismantled this one, and I'm going to part it out for electronics projects and to repair this one. So from 2 dead will become 1 working when I can be asked to fix it. Yeah. So let's get to it without actually cracking this one open. I can go back on the shelves now. And the first chip we look at is the brains of the operation. An AMD 8085 CPU. 8-bit, and I have the datasheet up here. Has 2 modes available, which is 3 and 5 megahertz. If we look up here, we've got a 6.140 megahertz crystal, made in the 40th week of 83 by the looks of it. And of course the chip is 1980. We've got some resistor networks here and some good old passives which contribute to the 555, which we will get to. So this runs at 8 bits, 3 and 5. I'd imagine it will probably... Actually, I can imagine it running at 3 megahertz because it's a lot easier to do a divide by 2 than taking a 1/6 off to make it 5 megahertz. But I cannot guarantee this for sure. I have no way of powering it up and measuring it because both these units are dead and this one was heavily vandalised. The next point is the 55 timer chip. Now this is a good old classic NE555 standard one, configured to mono stable mode, which is basically running as an oscillator, or oscillator I think is the correct word. Yes, I'm learning. Now it's interesting to find the crystal and this running, so this isn't doing the clock. However, I have noticed the input of it, because I thought they might have been doing a one shot as a sort of soft power on and off or something like that, but no, they're actually doing it. And the actual input goes all the way to what looks to be particular pins on both support chips and some of the power lines on the ROMs, which is an interesting change, that there's some sort of pulsing there. Perhaps it's a thinking about it, actually, they go to the... They actually go to... I would imagine they're probably actually... It's probably actually running as a clock for these 2 support chips. This one is unknown. I cannot find a data sheet no matter how hard I look. In fact, Google literally comes up with nothing on it. It is an L2079074. If I can find any... If you can find info on it, post a link in the comments to a data sheet or something, because it would be quite nice to actually know what this specific chip does. But looking at it, it does seem to interface with the ROMs, so I'm guessing it's probably... It looks like it interfaces with the ROMs anyway, so it's probably some sort of ROM controller. The EEPROMs are 2 pretty standard. A fair amount of these parts are AMD. Were made in 82, 26th week, and are from 1975. Then again, that might not actually be the date code. They've used Tipex to cover them up, their windows, and marked probably what are firmware numbers or addresses, because we've got 00 and 80, and they are 2716. So 16 kilobits. If you divide that by 8, you will get whatever that comes to. I'm hopeless at, I can't do mental maths, so grab your calculators, folks. And the other support chip, which if you bear with me I'll bring up the thing for it, ET251, which is this one, is what is known as a Programmable Communications Interface. Pretty much this is the main I/O chip for the whole system. And all that good jazz. We also have a relay for detecting whether it's plugged in, but this is essentially battery and it does battery charging. And then we get down to the more sort of passives. This is a voltage regulator, which I have actually researched, and you can get these. I cannot see the part number too well at the moment, so we just have to pretend you can. But it's a little mini switch mode regulator. It will be outputting 5 volts because it's a microprocessor circuit. This stuff runs on 5 volts, 6 volts if you're lucky. You can actually blow out the internals of chips at 6 volts depending on what they are. The one next to it is, let me just grab a look, 7473 it is. Is that it? Hang on. Right, the camera wasn't happy there. This is a 4-bit D-type register with 3 state outputs. So yeah, maybe the CPU didn't quite have enough registers to do the job. The 74LS153 is a dual 4-input multiplexer. And the, which one? That one is DS148. DS, let's just, is a quad line receiver. Once again, we're looking at a lot of I/O chips here. But bearing in mind the type of device is, you shouldn't be that surprised. The next one, the 74LS00, is a quad input NAND. I know that because it's in one of my electronics kits I have, and the 201 Labs, one of those. Very nice chip. It's remarkable what you can do with just some 4 NAND gates and a JK flip-flop, or a 74, I can't remember what the thing is in the middle, but 7474. The next one, which is a 138, which is here, I can't remember what these are, is a 1 of 8 decoder demultiplexer. So, demultiplexer, multiplexers, similar job, but the official chip ones can only do it in one direction, not like my design, which can do it in multiple, which is a bit of disadvantage. But yeah, this will demultiplex various signals for, I'd imagine that might actually have something to do with the keyboard input. The wires hanging off here were for the switch, which I pulled off because I needed to wire up this, which is my latest toy, which is a dosimeter. That is now working. As we can see, we've got some nice ribbon cables. These are the type you find on the Electron keyboard, also Husky Hunter monitors. Incredibly fragile, so just be warned with those. So when we flip the board over, we get to the keyboard obscuring a lot of the chips. However, before we move on to the chips, we have 2 DB25 male and female connectors, because everyone who needs, because this is back from the time when these were your main serials and the battery may die soon. Here we have various wire point-to-point inputs for bypassing cables or testing specific systems. Dip switches, I don't quite know how to use this thing, so you could set what points were linked to what, and if you look at the traces you notice they're pretty conformal to certain points on the connector. We've got lots of LEDs and driver transistors, which are no end for the cabling, buffering on the cabling, and also I'd imagine these ones up here would be display drivers, or at least part of it. So bear with me while we remove the keyboard. As I said, this is a parts unit, so don't freak out. I can use this keyboard elsewhere actually one day. I could desolder it, but that would take longer. I'd have to get kit out. There we go. No, we've still got, there we go. Off with the keyboard, which is actually quite a nice design actually. Let's take a quick look at it. Oh, we haven't got much record time, but yeah. Nice little design there. So, as we were saying, this keyboard, it has this pin, this pin, and this pin opposite of these basically work as our horizontal 4 pins, and the rest, as you'll notice, all these holes are where they hook up to the respective rows. So this pin will go to that row. This pin will go to the second row, to this row over here. This pin here, because there's actually 2 above the first button, goes to the first row. So yeah, you've got your standard sort of keyboard matrix. This is lovely and hackable, and it's got nice clicky buttons. Combine it with the case that's out there, thumbs up. Now on these you also have this lovely bubble LCD display, absolutely beautiful. Let's pop one of those out. Now I would like to give you a closer look, so I will try, but I really want to use these in a project, so we'll just zoom out because this thing does excellent macro zooming. Let's grab an extra light too. So this is the unit itself. Come on camera, focus. Oh, this light is not very good for this. But it's focused by the looks of it. So as you can see, you've got 4 dies there, lovely bubble memory. Over to the back, it's obviously multiplexed. There's no way you get that non-multiplexed with that many pins. It is a DL3. Is it? Am I looking at the right thing? Yeah, I am. DL340M. It's difficult to see through the camera display. It's better to look at with your own eyes, to be honest. But wonderful. One thing is, there's no pin 1 indicator. The only indicator you have is a missing pin here, which is an interesting turn of events, and it is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about a 12 segment display. I haven't actually looked up a data sheet for this thing, so I could just be speaking out my arse, but I have looked. But I have counted the actual individual segments that I can see. Of course they're very small and difficult to see. So the next point, we get back to the chips. Ah, how nice, they've even labelled them for you there on the silk screen. It's actually a very nicely designed board. There's no real bodginess to it at all. Now this is the main RAM chip. Bear with me while I bring up the thing. D8155, yep, that's it, see? This is, excuse me, distinctive characteristics. Well, it's a 256 word by 8-bit chip. So it's got about 256 kilobytes of static RAM. It's good old SRAM, so it'll be using 2 flip-flops conjoined to each other, both triggering each other. Essentially, if you got enough bits, I assume the 256 times 8 means it's 256 kilobytes. Well, actually it'd be 256 bytes, wouldn't it? Not kilobytes. That 256k would be wonderful for such a machine of the time. No, it'd be 256 bytes. We all make mistakes, we all have our moments. We've got plenty of decoupling caps over the whole thing just to remove any noise, because actually with digital electronics you can get a lot of noise created by the various switching from the various chips. And of course, as we get through, oh god, we can't really zoom into individual chips here, I'm afraid. I would love to, but A, the lighting won't have it, because I've pillaged a lamp from my, now what is my brother's room when he comes back. And it's actually got a capacitance sensor on it, so I can turn it on and off just by touching the metal. I haven't cracked it open to have a look at the circuit, but I will. Don't worry about it. Maybe we'll have a teardown of it. So first we'll look at the 74LS145, because I was actually quite surprised. Let me just find them on here. 7LS145, there we go. They are a 1 of 10 decoder driver open collector display driver. Now obviously you can have some sort of display driver on there, but what surprises me is the type of display driver they are. Now they're high output power because they're actually designed to deliver, let's quote you the things, the actual data sheet, designed to accept and provide appropriate outputs to drive 10-digit incandescent displays. So you definitely got the current there you need behind there. But the thing is, it's a 1 to 10 digit. This is like basically the equivalent of a low voltage Nixie tube chip. You put in a 1, it will output to 1 pin. You put in a binary 2, it will output to pin number 2, well Q2. That's it. And it could only go up to 9, which is a really interesting display choice. There's obviously some other logic going on there, because these are hex displays for showing hexadecimal. Well, at least I believe they are. They look like the right type for that. And there's 2 of them. You'd think you'd have 1 for each display for starters, so you know, the multiplexer, demultiplexer on the other side of the board. Potential display drivers, I think. Don't know what your theory is, but without actually doing continuity tests on the boards, I can't tell you for certain. The MC488 is these 2 chips over here at the bottom right corner for you folks. Are 1488. Let me just bring up the thing for them. They are quad line drivers. Now, bear with me. No, I have not installed screen capture software on this computer still. Now, the interesting thing about these, combined with another chip, is these are basically NAND chips, but this is a tri-NAND gate and an AND gate, which is essentially acting as a NOT gate because it's a NAND essentially, which is an interesting thing. Combine this with the 89 chip, which has its own input path. I'm thinking we have our actual hardware keypad decoder, which is an interesting way of doing it. I have not seen these chips before, so I don't know much about them. But there's a little output, so I'm thinking, keyboard matrix driver, anyone? If you know better, feel free to point it out in the comments, but that's what I'm going on. And yes, I should have done a nice pause, and then the camera could focus, and all that, but tough, I forgot. These 2 chips, there's the 89, which is only one of, and then the last lot is the DG302CJ, which is this one, which my finger is on, this one, and this one. And those are, what did I call them? DG, here we go. These are TTL compatible CMOS analog switches. Essentially seems to be like relays, essentially solid state relays, which is actually rather quite interesting if you ask me. I'm not quite sure what role they play in this particular circuit, but I'd imagine once again it's either going to be, display driving or keyboard matrix. And that is pretty much a detailed look. The design is nice. We don't have any fiducial points because the thing was built in the early 80s when we hadn't mastered mass electronics manufacturing, and these things would have certainly been produced on a smaller scale than most electronic devices. Computers then were expensive, and yeah, this is not the kind of kit you'd find these kind of kit used for testing null serial modems and all that good jazz. Other than that, there's not really much more I can tell you about it other than this detailed PCB look. So, to all of you who watched, thanks for watching. I hope you enjoyed, and I hope you continue to enjoy engineering. Goodbye. What is the biggest ant? An elephant. That joke doesn't even make sense. So you know what we say to that? Die. Die! Die! Stupid shitty cracker jokes. Burn in hell.